Have you ever pondered over the enigma of how our moon came into existence? It's a question that has captivated the minds of astronomers, scientists, and dreamers alike for centuries. This celestial body, our moon, with its silvery glow, has been a constant companion to Earth, silently orbiting and influencing our tides, weather, and even our nights. Its presence is so integral to our planet that it's hard to imagine a world without it. Throughout history, the moon has been a source of fascination and wonder, inspiring countless tales and legends. From ancient civilizations who worshipped it as a deity to modern humans who marveled at the sight of the Apollo astronauts walking on its surface, the moon has always held a special place in our collective consciousness. But the question remains, how did the moon come to be? How did this celestial object, which is so familiar to us, come into existence? This question has intrigued scientists for centuries, leading to a myriad of theories and hypotheses. From the early days of astronomy, different theories have been proposed to explain the moon's formation. These theories range from the moon being a chunk of Earth that was spun off into space, to the idea that the moon was a wandering celestial body that was captured by Earth's gravity. Each theory has its own set of proponents and detractors, and each brings its own unique perspective to the table. Like a cosmic detective story, the quest to understand the moon's origin is filled with twists and turns, each new piece of evidence adding another layer to the puzzle. It's a journey that takes us back in time to the very birth of our solar system and challenges our understanding of planetary formation. So, how did the moon form? Let's unravel this cosmic mystery. As we delve into the theories that scientists have proposed over the centuries, we'll explore the evidence for each one, and perhaps come a little closer to understanding the enigmatic origin of our moon. One of the earliest theories proposed was the Fission Theory. This intriguing concept posits that our moon was once part of the Earth. It suggests that at some point in Earth's early history it was spinning so rapidly that a chunk of it was thrown off, eventually cooling and solidifying into the moon we know today. This theory was brought to light by none other than George Darwin, son of the famed naturalist Charles Darwin. George, a significant figure in his own right, was a notable English scientist known for his work in astronomy and mathematics. He put forth the Fission Theory in the late 19th century, offering a bold new perspective on the moon's origin. However, as fascinating as this idea may be, it doesn't quite add up. The Fission Theory failed to account for certain key details about the moon, such as its composition and the specifics of its orbit. However, this theory failed to explain many aspects about the moon's composition and orbit. Another theory that emerged was the capture theory. This idea puts forward the suggestion that our moon isn't a native of our planet at all. It proposes that the moon was formed elsewhere in the solar system and was later snared by the Earth's gravitational field, a cosmic hitchhiker, if you will. The idea is fascinating, isn't it? A rogue moon, wandering through the vast expanse of space, until it was caught by the Earth's gravitational pull and forever became a part of our night sky. However, this theory has its own set of problems. One significant issue is that it struggles to explain why the Earth and the moon share such a similar composition. If the moon was a stowaway from another part of the solar system, wouldn't we expect it to be drastically different in its makeup? While intriguing, this theory too had its own set of inconsistencies. Then came the Condensation Theory. This proposition suggests that the Earth and the moon were born together like celestial twins from the same swirling solar nebula. Imagine two cosmic bodies growing and evolving side by side, their existences intertwined from the very beginning. Quite a poetic notion, isn't it? However, the condensation theory, though captivating, couldn't explain some crucial pieces of the puzzle. For instance, it struggled to account for the angular momentum of the Earth-Moon system. The moon's small iron core was another point of contention. According to this theory, the moon should have a similar iron core to Earth's, but observations tell us otherwise. The condensation theory, while it provides a beautiful image of our moon's origin, fails to align with the physical evidence we have. The mismatch between theory and reality led scientists to question its validity. Once again, the scientific community had to look for another explanation. Finally, we have the giant impact hypothesis, the most widely accepted theory today. This theory takes us on a cosmic journey back in time about 4.5 billion years ago, when our solar system was still in its infancy. Picture this, A Mars-sized body, often referred to as Theia, traveling at a tremendous speed, collides with our nascent Earth in a catastrophic, fiery impact. The cataclysmic collision was so powerful that it sent a vast amount of debris into Earth's orbit. This debris, a mix of Earth's outer layers and remnants of Theia, was captured by Earth's gravity and began to coalesce, forming a ring around our planet. Over time, this ring of debris slowly began to amalgamate, eventually giving birth to our moon. The giant impact hypothesis elegantly explains many aspects of the moon's composition and its orbital characteristics. Firstly, it accounts for the similarity between the moon and Earth's outer layer, as they both share common building blocks, remnants from the impact. Secondly, it explains why the moon lacks iron, which is abundant in Earth's core. You see, Theia's impact would have struck the Earth's surface, not its iron-rich core. Thirdly, the theory explains the moon's current orbit. The impact would have imparted a significant amount of angular momentum to the debris, setting the moon on its unique path around the Earth. Also, the moon's slightly tilted orbit can be attributed to the off-center impact by Theia. However, like all scientific theories, the giant impact hypothesis is not without its controversies and unanswered questions. For instance, it struggles to explain the moon's volatile elements and the precise dynamics of the moon's early formation. Despite these limitations, the giant impact hypothesis, with its compelling evidence and explanatory power, stands as the most plausible explanation for the moon's formation. It paints a picture of a violent yet fascinating cosmic ballet that eventually led to the creation of our closest celestial companion. So, what have we learned about our lunar companion's birth? We've dived into the depths of 4 primary theories that have sought to explain the formation of the Earth's moon, each with its unique perspective and evidence, each contributing to our understanding of this celestial enigma. First, we explored the Fission Theory, the idea that the moon spun out from the Earth's early, rapidly spinning molten mass. This theory, appealing in its simplicity, was bolstered by the moon's composition, remarkably similar to the Earth's mantle. However, it fell short in explaining the moon's angular momentum and the dynamics of such a process. Then, we ventured into the capture theory, the notion that the moon was an interstellar vagabond captured by Earth's gravitational pull. This theory accounted for the differences in the isotopic compositions of the Earth and the moon, but it struggled to elucidate how such a large body could be captured without being broken apart or causing catastrophic damage to the Earth. Next, we delved into the condensation theory, positing that the Earth and the moon formed together from the solar nebula. This theory could explain why the Earth and Moon share many similarities in their compositions. However, it couldn't convincingly account for the differences, especially the Moon's lack of iron. Finally, we arrived at the giant impact hypothesis, the prevailing theory today. According to this hypothesis, a Mars-sized body named Theia collided with the young Earth around 4.5 billion years ago. The impact was so colossal that a cloud of debris was ejected into space, which eventually coalesced to form the Moon. This theory elegantly accounts for many of the moon's unique characteristics, its composition, its lack of iron, and the differences in isotopic compositions between the Earth and the moon. It also explains the moon's large size relative to the Earth and its angular momentum. Despite its strengths, the giant impact hypothesis is not without its weaknesses. Some details about the specifics of the impact and the subsequent formation of the moon are still being worked out by scientists. However, it's the theory that best fits the evidence we have, and as such, it's currently the most widely accepted explanation for the moon's birth. While the exact process of the moon's formation remains a subject of research, the journey to unravel this mystery reminds us of the vast complexities and wonders of our universe. The quest to understand our lunar companion's origin is a testament to human curiosity and our unending pursuit of knowledge. It's a journey that continues to inspire, challenge, and surprise us, reminding us that our universe is a place of profound wonder and mystery waiting to be explored.